Okay, so today what we're going to do is we're going to begin our lessons in algebra, and we're going to be talking about something called algebraic expressions. Now, before we can talk about algebraic expressions, we need to talk a little bit about what algebra means. And I know you had some algebra, so you had some algebra in your classes in year 7, yeah? Most of you? Yeah? Okay, good. But we're gonna start over and just kind of talk as if you haven't ever heard of anything yet. And so that we can learn the language of it. Because if you know the language, right? If I came in here and taught this class in French and you didn't speak French, you'd have some trouble, right? Well, a lot of the problems that students have in math is because they don't know the language of the mathematics, which means they have trouble, right? So we're going to start there. So the first thing I want to do is talk about arithmetic, because that's all we've been working with so far. Remember, we've got 4 operations in arithmetic. You can add, subtract, good. What else? Multiply, or what?
Divide.
And divide. You all okay with my abbreviations there? Right? Guess what? When you start with algebra, you can add, subtract, multiply, and divide. So the mathematics that you already know is the mathematics that you will use for algebra, statistics, calculus, all the way, right? So you never have to really learn anything else other than add, subtract, multiply, and divide. Now, those are the operations. There are lots of ways, an infinite number of ways you can put them together to do new things. And that's the part that you have to learn, okay? So, do I have to learn all kinds of new mathematics? Nope. Add, subtract, multiply, and divide. But I need to know how to make those work. So in arithmetic, we just have things like 2 plus 4, right? What operation is indicated here?
Plus.
Yep, and so 2 plus 4 just gives us 6, right? Well, the only difference between arithmetic and algebra is in algebra, we're going to introduce the idea of an unknown number. You do this all the time. You just don't realize you're doing it. Have you ever asked someone what time it is? So, what time is it right now?
It's 9:39.
9:39, right? Everybody agree? Well, did I ask you for a number? I asked you what time it is, didn't I? But you gave me back an answer that is a number. Now, what if I asked you that same question in period 5? Would you give me the same number? No. So you see that I asked you the same question, what time is it? But the answer you gave me wasn't the same because the context was different, right? And that's what's going to happen in algebra. We're going to have unknown numbers that we don't know the values of. Here we knew 2 and 4, right? So we could go ahead and do the math. But in algebra, you're going to have some unknown quantities. And these unknown quantities are called variables. Okay? And the reason they're called variables is because their value can vary depending on what sentence they're used in. Okay? Do you use the word what only to indicate time? Nope. So, what is this object on my desk? Still the word what, isn't it? Okay? So, what color is her sweatshirt or her hoodie? Yellow, right? It's still the word what, isn't it? So you're still using the same word over and over, but you're using it in different contexts, so it gives you a different answer. And that's why x can be 5 in one problem, x can be 25 in another problem. It just means some unknown number. Would you rather write some unknown number, or would you rather write x? You bet, right? We don't want to have to write all this stuff if we don't have to, and that's all we're doing. So all these unknown numbers, these variables, are simply the letters. And you can use any letter you want, right now. And most of the time when you're first starting algebra, we use letters that make sense for what we're doing. So for example, if we're counting up the number of tables, we might use what letter? T for table, right? Now, but that might get confusing if we're also if we're doing another problem with time, but we could also use T. But it doesn't matter because your sentence will tell you what you're trying to find anyway, right? So if I want the number of students, what might I use? S, right? Okay. Now, do I have to?
No.
Nope. And you'll see as you move forward in algebra, they'll stop doing it and they'll just use X for everything. Okay, hold on just 1 second. You had a question back there?
I was just going to ask you an unknown number. So instead of writing an unknown number, people just write letters instead.
Exactly. That's exactly what's happening. Yes, ma'am.
Could you just use ST for students?
Well, no, because if you use more than one letter, that indicates two unknowns. And we're going to look at that as we go. So you want one letter to represent the unknown quantity. Okay? Excellent question, though. And you're going to see that happens. Now, when we introduce the variables or the letters, what happens is we have more things to use when we're writing our mathematical sentences, right? So we have to start thinking a little bit differently than just arithmetic. So what we have now is we have what are called terms. So now terms are the building blocks, whereas in arithmetic, it's just the numbers with the building blocks, right? We had numbers and symbols. This time, now we're going to have terms. And all terms have exactly 4 parts. Now, we're going to start off slowly, so you're not going to see all 4 parts, right? But it's good to know that they're there, and it's good to understand that they're coming, right? Wouldn't you like to be forewarned? So, the first part of every term is something called its sign. Now, for us at our level, what we're going to the signs are those pluses or minuses that are in front of the numbers. For us right now, we're still going to think of as a plus as what operation? Add, and a minus as subtract. Okay? So we won't be dealing too much with the sign. But know that if the first part of every term, I'm sorry, I didn't number that. If the first part of every term is its sign, or a plus or a minus, then how can I know when I'm about to hit a new term? I'm going to see a plus or a what? Minus. So the terms will be separated by pluses and minuses. Well, no, because that would be, and we'll talk about that. Hold on just a minute. So it's only plus and minus. Okay? Now, the second part. Now, here's a big math word for you, but you've probably heard it before. It's the coefficient. Okay? Now, the coefficient simply means the number in front of the letter.
So like 1A would 1 be a coefficient?
Exactly. So if you had 4s, then 4 would be the coefficient for s, right? Okay? And those things are always put together with multiplication. And we'll talk about that in just a second, and put together some examples of terms, and then we'll break them apart. Okay?
Yeah.
The next part is the letter, and the letters are always called what? Variables, right? They're variables because their values can vary depending on how they're used in a sentence. And then finally, whether you see one or not, every variable has an exponent, which y'all call indices, right?
Can you call them exponents?
You call them exponents?
Yeah.
Excellent. I love that. Then I don't want that then. Okay. Exponents, because I like exponents, because that's what I'm used to. Yes? Of course. Now, okay. All right, so an exponent. And you know what an exponent is. It's a little number that floats in on the upper right-hand side, right? It means multiply the number times itself over and over.
So like the square?
So a square is a type of exponent, exactly. Right? Like when we were doing area. Okay. So what I'm going to do is I'm going to write down a few terms, and we're going to look at all the pieces of a term. And then we're going to talk about building some sentences and actually going to the exercises. This is all background information, right? So here we go. So let's say I have negative 4a to the third power. This is an example of an algebraic term. Can anybody tell me why I call it an algebraic term? Just sing out. Because it has a variable in it. Right. That's all that makes algebra different from arithmetic, is you have the introduction of those variables, right? So this is an algebraic term because it has a letter in it.
Should we write it down?
Okay. You bet. If you want to write that down, you're certainly welcome to. Okay. So it is algebraic because it has a letter in it. Now, okay. All right. So it's an algebraic term because it has a variable in it. So let's label the parts. What is the first part of every term? It's what? Sign. Good. And that's just that plus or minus in front of it. And what does this one have in front of it? A minus, right? So, and you may already know that minus, we call that what sign? Negative, right? Remember, I don't know your background, so I'm having to go from work blind here. Okay? What's the second part of every term? The coefficient. Coefficient, which just means the number part. So what is the number here? 4. Right, good. So the coefficient, which is the 4. Now these two parts of a term are always taken together. Right? You need to be able to identify one from the other, but they always go together. They're never separated. Right? Do you get a new last name because you go somewhere different? Nope. Your first and last name are hooked together. Does that mean you have to use them both every time? Nope. But they're always the same, aren't they? Now, and they literally tell you how many you have. You do this all the time. 3 cars in the parking lot. How many cars? 3. And they're cars, right? So this tells you how many cars. So it's the number in front that tells you how many. Just like you always do. Okay? Excellent. What's the fourth part?
What about the third?
Oh, why can't I write 3? Okay, let's do that. How about that? The variable, which simply means the letter, right? Which in this case, what is the variable or the letter? The A, right? Now, it also has an exponent on it, but that's not the third part, right? That's the fourth part. So make sure you don't say A to the third. This is an A. Okay? And then finally, the last part is the what? Exponent. And what is the exponent in this particular case? The 3, which we also call as cubed, right? Means multiplied over and over times itself. And these two parts of the term also go together. They're like the word cars. In other words, they name the term. Okay? So here I have negative 4a to the thirds.
Why are they together?
Because you'll see when we start dealing with things that are called like terms later, that the exponent makes a difference. Because is an a the same as a times itself 3 times? In other words, is a 2 the same as 2 to the second power? No, 2 equals 2, but 2 to the second equals what? 4. So the exponent literally makes it a new number, right?
Is that why they're together?
Well, and yeah, that's why they're together, because the exponent makes the a different, doesn't it? Okay? And that's why they're put together, right? Because there was no exponent here, so the 2 just stayed at 2. But the exponent here made a huge difference. It turned the 2 into a totally different number, didn't it? Okay? All right. So let's talk a little bit about operations. And the reason is because everything in algebra is about shorthand. Do you know what shorthand means? You don't write out the whole word. You just use a symbol to represent the word, right? So what's happening is everything in algebra is written in very small pieces. And the operation that it changes the most is multiplication. Oops. If I could write and spell multiplication, that would be good. It's the one that looks the most different. If you're going to add, still a plus. If you're going to subtract, still a minus. But multiplication and division, and especially multiplication, are the biggest ones. So let's say that I wanted to multiply 4 times A. Okay? Well, traditionally, we use the x to mean multiplication. And you're still going to see it in your book, and you can still use it. But is there something wrong now with this notation? Sure.
I was going to say, because there's no answer.
Well, anybody think, why wouldn't I want to use x?
You could confuse it for the variable x.
Right. Wait, so x could actually be a number, or it could mean multiplication. Now, in the book, what they'll do is they'll just type it so that you can tell. They use italics, right? That soft little, yeah. So you can tell the difference between a letter x and the multiplication x, right? But for us, I would really like you to get out of the habit of using that. Because later, you're going to be forced to get out of the habit of doing it. So know what it means, right? But try to do something different. So most of the time, even at lower levels of algebra, we're taught to use that dot to represent multiplication. Now, I don't see it very often in your textbooks.
We usually just do side by side.
Yeah, we don't.
Without the dot.
Perfect. Good. We're going to go there. Good. But anytime you're multiplying a letter times a number, you don't even need a symbol. Now, can you do that with numbers? Does 2, 3 mean 2 times 3? No. Numbers or arithmetic have to have symbols. But if one of your things that you're multiplying is a letter, you don't even need a symbol at all. If you have multiplication is the only operation that you can do where you need no symbol at all. Every other operation you have to have a symbol, but multiplication.
But you might think that it's 4A.
Right? Well, 4A literally means 4 times A.
Oh.
Yeah, so it is. Mm-hmm.
If we were going to do 2 variables times each other,
You
then
bet.
we would use the dot. Oh, okay,
Do I need a dot? Nope. Anytime you see two things that aren't the same, side by side, what do you always assume it to mean?
so does that mean it's okay for us to not use it?
Absolutely. Right? So it means multiplication. Now, the only reason we keep the dot is because something like that, right? Because you're not going to lose the numbers. Yes.
When we're doing like normal arithmetic calculations, like with just numbers,
Mm-hmm.
do you want us to use the dot or the X?
Either way, whatever you're more comfortable with. Okay? I would prefer you wean yourself away from the x because of where you're going. Okay? Now, all right, so all of these mean to multiply those things together. But these are the two preferred forms. Okay? All right. Now, division is different, but we're not going to be doing any division yet, so we'll talk about that later. So we'll deal with that as we need to. There are certain rules that you also need to follow when you have terms. And that is that they need to be the way that we introduce them. The sign always comes first, then the coefficient, which is the number, then the letter, right? So, if you have 4 times A, then that would be simply written as 4A, right? Notice that the number came first. So would it be okay if I said y times 6 is y6? No, don't do that. And one reason is because it makes it really easy to confuse that 6 with not a coefficient. It looks like an exponent sometimes, right? So instead of y6, what would I write?
6Y.
6y. Good. So the number always comes when? The number always comes in front. There you go. This comes first, right? Now, let's say that I have several different letters to multiply together. So let's say I'm going to take C times D. Okay? Well, for letters, if you have all letters, then what do you normally do with letters when you're just thinking about letters? Is there an order for letters?
Alphabet.
Alphabet, exactly. So you always do them alphabetically. Okay? So C and D, which one comes first in the alphabet? So you're just going to write CD. But what if I have A times, so S times A times W. Okay, so which one comes first? A, then what? S, then what? W. Okay?
I was wondering, so if the 4A one, so the answer is for that is just 4A.
Right, because we don't know what A is, right?
Yeah.
So we can't do the math. The best we can do is just rewrite it. So make sure you remember that anytime you have more than one letter, it's important to put them alphabetically. And no matter where the number is, the number always comes where? In the front. Okay? Good. All right, so that's some background information. The last thing I want to do is I want to talk about something called an expression, and hopefully you've seen this before, but if you don't, we're going to remind you. That's simply a mathematical sentence. So a math sentence. Does that mean it has to be algebraic? No, I didn't say an algebraic sentence, right? So you can have an expression that's just a collection of numbers, right? So an expression is simply a collection of terms. And I forgot one. 3 is a term. Is it an algebraic term? Nope. It's something called a number term. So don't forget, numbers aren't going to go away, right? We're just adding into it. So I forgot to write that down for you, number term. All right. So what expressions do not have is they can't have an equal symbol. They can have plus, they can have minus, they can have numbers, they can have letters, they can have anything except for what?
Equal.
Then equal symbol. Okay? Because if you add the equal symbol, then it becomes not an expression, but an equation, which is something we'll look at later too. But right now we're just starting with expressions.
Sorry, I was going to ask, so you can't use the equal symbol in algebra?
No. And you can't have an expression if it has an equal symbol.
How do you know if it's an expression?
Doesn't have an equal symbol,
Oh, okay.
right?
Yeah.
Because if you have an equal symbol in it, then it's no longer an expression. It's something called an equation, which we'll study later.
So the ones that you were doing, that you were doing just before, like how you did 3 multiplied by A.
Exactly. Those are expressions, and that's what we're going to look at today and examples of.
Meaning we're not actually answering the question. We're just rearranging it in the right correct.
Well, you're going to be putting it in the right order, and we're going to be able to write things using unknown quantities. Okay, you'll see. Hold on. Let's look at the lesson. All right. So, all right. So what we're going to do is we're going to talk about writing algebraic expressions. Okay. So first of all, who can tell me why or how I know that it's algebraic? What's it got? Variables. Excellent. Right. Good. And it's an expression, and the way I know that it's an expression is by knowing what it doesn't have. It doesn't have an equal symbol. There you go. So we know they're algebraic expressions because they have a letter in them and they don't have an equal symbol. How hard is that, right? Now, if I had just told you to write algebraic expressions, it sounds pretty impressive, right? But really all you're doing is writing sentences that have letters in them and no equal symbol. Okay? So if you know the language, math is easy, right? Now, so let's look at some examples. So look at example 1 there. It says, Brent, Scott, and Takesha are sharing a bag of peanuts. Okay? Suppose Brent eats B peanuts. I don't know why they didn't just call it P, right? But B peanuts. And Scott eats 1 less peanut than Brent. And Takesha eats 3 times as many peanuts as Brent. We're going to write an algebraic expression for the number of peanuts eaten by each one of them. So if Scott, remember that Scott Okay. He's the second one. And so Brent eats how many peanuts? B. It's probably where they get the B is from his name, right? Brent. Okay. But Scott eats one less. So were you increasing, decreasing? What are we doing there? Decreasing. We're taking away some, right? So what operation does that indicate? Subtraction. We're going to minus, subtraction, exactly. But we start with the same number of the peanuts that Brent has. So we're going to start with that, and then we're going to take away how many peanuts? 1. So subtract 1. So the original number of peanuts was B, right? Because we're basing everything on how many peanuts that Brent ate, and then we're just subtracting 1. So B minus 1. And that's what an algebraic expression looks like.
So is that the answer?
That's the answer. Okay? So let's do Takesha. It says Takesha ate 3 times as many as Brent. So how many did Brent eat? B. We don't know, but we're calling it B, right? And she ate 3 times as many. Well, 3 times means what operation? You bet. So I'm going to put B times 3? No. I could write that, but I'm not finished, am I? It means the same thing, but how should I write this? 3 times B, or even better, what? 3B. Okay? Now, they wrote using the multiplication symbol, and they're going to continue to do that because they want you to focus really heavily on the what operation. It's right now they're focusing on getting the operations right. But I think y'all are good enough that y'all can just start writing it the proper way in the first place, yeah? Yeah? You think? I'm good. I'm sure. Okay. How does that look? Okay. So it looks like a couple more. Exercise 7A1. Suppose a bus has P passengers. Again, they're using P because passengers. Oh, yeah. You should be writing these down for sure. Okay. So 7 passengers get off at the next stop. So how many passengers are now on the bus? Okay. So how many passengers did we start off with? P. We don't know how many people, but there were P passengers on, right? So people got off. So are we adding or subtracting? Subtracting. And how many people got off?
7.
So it's simply P minus 7. Now, can I rewrite that as negative 7P? No, there's no multiplication in this, is there? That means minus 7 times P. So it's not the same thing. So be careful if you're going to try to rewrite it. Make sure that the only way you can write it as the number times a number with the letter is if it's multiplication. Okay?
Oh, and the thing where it comes first is...
Yeah, where it comes first, that's always multiplication, right? When the order doesn't matter when you're doing this. Usually we always put, if we're subtracting from it, we always put the thing we're subtracting from first, right? So P minus 7. Excellent. That's what they're trying to get you to see here. Kurt, Robbie, Leo play on the same hockey team. Last season, Kurt scored G goals. So do I know how many he scored? Just G. We don't know. So we're just going to call it G. Sorry? So is it easier to write G or Kurt scored an unknown number of goals? You bet. So you see where they come up with this. It's just a matter of shortening it. They used to use symbols. The ancient Egyptians just used a symbol to stand for it or something. So, and that's where it comes from. So there we go. Kurt scored G goals, right? So I know that Kurt equals G goals, right? Robbie scored 3 more than him. So for Robbie, he scored the same number as him, but how many more? 3 more, so that means plus 3, right? Don't forget that it's based on how many that Kurt did, so it's still going to have the G in it. And then finally, Leo scored twice as many goals as Kurt, so that's twice as many means multiply by what number? 2, twice. You're going to see that a lot. Okay, so twice always means multiply by 2. So is that the way I'm going to write it? Do I have to write 2 times G? No, I could just simply write it as what? 2G. Could I write it as G2?
No.
No. Number always goes first, right, when you're multiplying. How does it look? Are y'all so happy with this? Did I make it seem worse than it was?
No.
Good.
Do you have to go sideways?
Right. When you're writing an expression, you're going to write it out like it's a sentence. So not up and down. Okay? All right. A man is N years old. So that means everything is going to be based on the letter what? N. Okay? So he's N years old. How old was he? 12 years ago. Now, years ago, is that future or past? So that means we're not going to be adding, but subtracting. So what is that going to look like? N minus 12. Rocket science, yeah? You loving this? The man's wife is 6 years older than he is. So for the wife, it's still based on his age of N years, but she's what? 6 years older, which means
N plus 6.
N plus 6. 6 years more. So an increase of 6 years. Okay, excellent. The man's mother is twice his age. And twice is simply another way of saying multiplied by what? 2. So it's 2 times N, but even better, what? 2N. Now, when you see the answers written, they're going to be given as 2 times N. But I'd like for you to know the difference. Okay? I wouldn't count off if you wrote 2 times N. Okay? Look at number 5. My neighbor has X cats. So what does X stand for? The number of cats. Exactly. So I'm getting a little more definition in here each time because I want you to make sure you know that that's what the X stands for. All right? Write an expression for their total number of, and then we have tails, eyes, and legs. Okay?
So the X eyes, the X tails.
Yeah. So we have X cats, and if we're doing a total, we usually think of that as addition. But are we adding tails to these cats? No. This just means we have a multiple number of cats, right? So it's going to be multiply. So, but it doesn't tell me how many tails. Kind of know that though, right? How many tails does a cat have? 1. So it would be X times the number of tails, which is 1. And how could you write that? 1X. But if you just have a car, do you say, or if you have that table, do I say, oh, that one table? No, you just say a table, right? So anytime it's 1X, we can simplify that even further by just writing what? Just plain old X. So there are X number of tails. The same number of tails as cats, isn't it? Okay? Does it make sense? Now, eyes. X times what? How many eyes does a cat have? 2, which we will simplify to write it as what? 2X. Excellent. Not bad in writing. Yeah, it's not too big of a stretch, yeah? Okay. And legs. How many legs does a cat have? 3. Well, it depends on your cat. If it's had a really rough life, which is the same as writing what? 4X. Now, yeah, not every cat has 4 legs, though. Okay. But we're going to assume they're all whole cats. Okay? How's it looking? Now notice I keep writing those equal symbols. Now that doesn't mean I've changed it to an equation. I'm just saying that this thing is equal to that thing. Okay? This is still an expression because that's the finished answer. Okay? So maybe I should change those to arrows. How would that be? Because I don't want to mess with y'all too much. So I'll change those to arrows so you don't get too confused. All right? Now, let's see. Strawberries. Okay. In the fridge, there are 2 punnets with strawberries in them, plus 4 strawberries left over. Write an expression for the total number of strawberries if there are 6 have been put into each punnet. How many punnets? 2 punnets, right? So every one of them, there's still just going to be 2 punnets. So 2 punnets for each one, right? And how many strawberries are in the first section? So each punnet has 6 in it, right? And then there's some left over. What?
4.
So that means 4 strawberries left over, right? Now, how many punnets do I have? 2. How many strawberries in each one?
6.
How many left over?
4.
Do I have any unknown quantity here? No. So is this even going to be an algebraic expression? No, this is going to be an arithmetic expression. And you had it, I think. What did you say?
It's 2 times 6 plus 4.
Exactly. 2 times 6 plus 4. Now this one I could actually solve, couldn't I? Because I have all numbers, right? And it would tell me how many strawberries that we had total. Yeah? But that's not what they're asking us to do. They're just asking us to write it out. So if you don't have any unknown quantities, then you're not going to have an X or a Y. So if you see, every time they just change the number of strawberries. Now look at the bottom one. If, I don't even know what that symbol is. Is that an S? Okay, good. It's just prints up on it. Strawberries, of course. If S strawberries have been put in each punnet, now do I have an unknown quantity? Yes. So this one is going to be algebraic, right? So if it's S strawberries have been put into each punnet, still have how many punnets? 2 times how many strawberries in each one?
S.
Plus how many strawberries left over?
4.
And can I simplify that a little bit?
Yes.
Instead of 2 times S, I could just simply write. Now, can I add the 4 and the 2? No, because a 4 is a number and an algebraic term, an S term is an S, right? Could you add a car and a 7? No, right? So make sure you don't try to put things together that you can't. Well, the sillier it is, the easier it is to understand. All right.